Hey guys, what's up? It's Miss Rankin. I'm going to give you the test review. Hopefully you'll go through this a couple times tonight and be ready for your test tomorrow. All right? So, here we go. I'm going to start with number 1. And what's the sign of W? I know that the sign is the opposite over the hypotenuse. So if I'm at W, this 11 is opposite. The hypotenuse is 18. It wants the tangent of C. The tangent is the opposite over the adjacent. Okay? So if I'm at C, the opposite's 7. The adjacent is 11. So it's 7 over 11. I'm going to go ahead and put an H right here because the adjacent and the opposite can change based on where you're standing, but the hypotenuse never does. It's always the side that's opposite the right angle. Okay? So go ahead and do that whenever you get to your triangles. Go ahead and label your hypotenuse with a H so you don't get confused. All right? Cosine W. The cosine is the adjacent over the hypotenuse. All right? Adjacent is 7. Hypotenuse is 18. All right? And then sine C. The sine is the opposite over the hypotenuse. So sine C is opposite over hypotenuse, 7 over 18. All right? Number 5 wants to know, where are you standing when the sine of an angle is 7 over 18? Keep in mind, we never stand at the right angle, okay? So, if you're standing at C, remember your sine is your opposite over your hypotenuse, okay? So, where am I standing so that my opposite side is 7? Well, here's, if I'm standing at C, my opposite side is 7. So the sine of C is 7 over 18. All right? Now, it wants to know where are you standing so that your tangent, which is your opposite over your adjacent, is 11 over 7. So, if I'm here, my opposite's 7. It's not C. Keep in mind we never stand at our right angle. So let's try W. Is my opposite 11 and my adjacent 7? Yes. So this is W. Now they want to know which of these 4 choices will correctly solve for C. I've talked about this with my students. Hopefully you remember on your test tomorrow that the angle of elevation and the angle of depression always go right here, and they're always the same. Take the pass. So if they give you this angle, you can go ahead and write it right here and then solve your right triangle as normal. All right? So this one says sine of 15, which is opposite over hypotenuse. Sine of 15 is 1400 over C. That's right. That works. Okay? This one says cosine of 15, which is adjacent over hypotenuse. Cosine of 15 is 1400 over C. That's not right, because the cosine of 15 is, the adjacent side to this angle is B, not 1400. So that one can't be right. Now they say the cosine of 75. What? There's no 75 in this picture. Where would they get 75 from? Well, if you do 90 minus 15, you get 75. Why would you do 90 minus 15? Couple reasons. This is a right angle. So this is a 90-degree angle. So you know together they have to be 90. You could also do 90 plus 15 plus whatever is this angle, and you figure out this is 75. So now we're standing here. So now we need to test this one. Okay? The cosine of 75, cosine is adjacent over hypotenuse. So the cosine of 75 is 1400 over C. That one also works. Okay? Sine of 75, which is opposite over hypotenuse, is 1500 over C. That one's not correct. Okay? Now it wants us to write an equation that will solve for B. It says round to the nearest tenth. Okay? This is B down here. Since you have both angles, you can stand wherever you want. It doesn't matter. I'm going to stand right here at 15. Okay? So, I'm solving for B, so this is my adjacent side. And I have 1400, which is my opposite side. Okay? The tangent function is the one that uses the opposite and the adjacent. So I'm going to say tangent of 15 equals the opposite over the adjacent. Okay? When x is up high, we multiply. When x is down low, we divide. So I'm going to say B equals 1400 over tan 15. That goes in my calculator. When you sit down to take your test, you want to make sure that your calculator is in degree mode. Okay? You do that by clicking mode, going over to degree, and clicking enter. Then click second quit. Okay? So now I'm going to do 1400 divided by tan 15. And that's 5224 point. It says to round to the nearest tenth. That's the first decimal place. So I'm going to look here at the 8. I'm going to see what the next number is. It's 7, which makes that 8 turn into a 9. So this is 5224.9 feet. Now all we're doing is setting up trig ratios. Okay, this goes pretty quickly. What's the sine of G? Well, the sine is the opposite over the hypotenuse. So that's Q over P. I'm going to go ahead and put an H here at P because my hypotenuse never changes. All right, so this is Q over P. All right, now it wants the tangent of B. The tangent is the opposite over the adjacent. That's R over Q. Now it wants the cosine of G. Cosine is adjacent over hypotenuse. So that is cosine of G, adjacent over hypotenuse, R over P. Cosine B. Cosine is adjacent over hypotenuse. So cosine B is Q over P. Okay. Here, this just means to multiply them. Sine G times tan B. So I'm going to do Q over P times R over Q. Okay. Now, when you multiply these, you get QR over PQ, but look, the Q's cancel out. So you're left with R over P. All right? So, let's do number 10. It wants to know, where are you standing when the tangent is 8 over 15? Well, the tangent is opposite over adjacent. Okay? Same thing here. Where are you standing when the tangent is 15 over 8? The tangent is opposite over adjacent. All right? So let's look at this. This is 15. Why is this 15? Because it's the same as this, and this is 15. And this is 8 because it's the same as this, and this is 8. So I'm just going to go through all my angles and see what happens. If I'm at angle 1, my opposite over my adjacent is 8 over 15. So this is angle 1. If I'm at angle 2, my opposite over my adjacent is 15 over 8. So angle 2 goes down here. If I'm at angle 4, my opposite over my adjacent is 8 over 15, which is here. And if I'm at angle 3, my opposite over my adjacent is 15 over 8, so angle 3 goes here. Since this video started, I don't think I've mentioned what opposite and adjacent means, okay? Hopefully by now we know it, but if we don't, that's okay. This is a fine time to learn it. This is always going to be your hypotenuse, so you can always label that H. It's always opposite your right angle. It's always across from your right angle. The word opposite means across from. The side that's across from your right angle is your hypotenuse. The side that's across away from the angle that you're talking about is your opposite side. The side that is next to it is your adjacent side. Adjacent means next to, opposite means away from, okay? Now, let's do this. I want you to round this to the nearest thousandths, okay? I want you to round this to the nearest thousandths. This is as easy as putting it in your calculator and properly rounding, okay? Let's look at it. Sine 71 just goes in your calculator as sine 71. The thousandths is 3 decimal places, so I'm going to look at my third decimal. I'm going to look at my third decimal place. I'm going to see what the number after that is. This is a 5, which changes that to a 6. So this becomes 0.946. All right? Tan 53, all I do is put that in the calculator. Go to my third decimal place. It's a 7. The number after the 7 is a 0, which doesn't change the 7, so this just stays the same. 1.327. All right. Cosine 28, 0.8829. The number that's after the third decimal is a 9, which changes that to a 3, so that becomes 0.883. Okay. This is also putting in the calculator, but you're just using the inverse, okay? So you're going to do second sine 12 divided by 7. How did I know to do the inverse? That's because it did not, sorry, it's 17, because of that little -1. That's how I know to do the inverse, that -1. 44.9, we're rounding this to the nearest tenth. I'm going to change it up on you. We're going to round these to the nearest tenth. So this is 44.9. There's a 0 after the 9. That doesn't change the 9. Okay. Inverse tangent of 8 over 12. 33.69. There's this 9 after that 6. That changes that 6 to a 7. Okay. Inverse cosine of 10 over 21. 51.56. That the number after the first decimal place, the tenths place, is a 6. That makes that the number in front of it go up 1. So our 5 becomes a 6, so it's 61.6. All right. Let's move on to the back. We got an air balloon, and a car here, okay? The ground distance, that's the bottom. The ground distance from the car to the balloon is 321. The angle of elevation is 51.25. Remember, we talked about this earlier. The angle of elevation and the angle of depression, doesn't matter which one they say, they both go right here. Okay, and it wants to know how high is our balloon, so this is our x. Okay, so if I'm standing here at the car, this is going to be my adjacent side. All right, and this is going to be my opposite side. It's away from me, it's opposite. This one's my hypotenuse. The hypotenuse doesn't matter to me in this problem. I'm not looking for the hypotenuse, and I'm not given the hypotenuse. The hypotenuse is not involved in this problem. So the adjacent and the opposite are, that's the tangent. The tangent uses the opposite over the adjacent. Okay, so the tangent of 51.25 equals the opposite over the adjacent. Okay. When x is up high, we multiply. So I'm going to say 321 tangent of 51.25 equals x. That goes in my calculator. Okay, this one's really interesting. I want you to round to the nearest tenth here, okay? So we look at our 9. The number after the 9 changes the 9 to a 1, right? So everything rounds up to 400, right? Because this makes this go up, this, which turns this to 1, so we change that to 400. So this is x equals 400, okay? Now, something we forgot to tell you on this problem is that this right here is 25.7 and this is 6, okay? When you take your test tomorrow, you will have a problem that looks a lot like this, but these numbers will be given. You won't have to figure them out. We're learning how to figure those numbers out on Monday. I did tell some of my classes earlier in the day a different number here. I was wrong earlier, but it doesn't matter. The process is still the same, and that's the important part, okay? Because on your test tomorrow, the number will be different as well. All right, so when you get to this problem on your test tomorrow, do not freak out about this polygon. We haven't done polygons yet. I'm not testing you about polygons. I'm testing you about right triangles. So come over here, draw a right triangle, label it correctly, and don't worry about your crazy polygon over there, okay? So it wants us to solve for r, all right? So here's r. R is our hypotenuse, okay, because it's opposite our right angle. So I have this angle, and I have this side. This is opposite me, right? If I'm standing at this angle, the 6 is opposite, and I'm looking for the hypotenuse. So opposite and hypotenuse is sine. So I'm going to do the sine of the angle, 25.7 equals the opposite over the hypotenuse, okay? When x is down low, we divide. So r is equal to 6 divided by sine 25.7. Put that in your calculator. I want you to round to the nearest tenth here. So I'm going to do 6 divided by sine of 25.7. That's 13.83. The 3 does not change the 8, so we leave it as 13.8. Okay? Now we're going to solve for h, this part. Okay? Again, we're still standing here. The h is my adjacent side. All right? So I have my opposite side, and I'm looking for my adjacent side. The tangent uses opposite over adjacent. So the tangent of the angle, 25.7, is equal to opposite over adjacent. All right? When x is down low, we divide. So I'm going to say h is equal to 6 divided by tan 25.7. Put that in your calculator. We're going to round to the nearest tenth. And I get 12.46. That 6 turns that 4 into a 5, so it's 12.5. We're almost done. These last 4 are pretty easy. So we're standing here at the 29. How do I know I'm standing at the 29? Because that's the angle they gave us, okay? I'm looking for x, which is my opposite, and I have 24, which is my hypotenuse. So the sine is the one that uses the opposite over the hypotenuse. Sine 29 equals x over 24. When x is up high, we multiply. So I'm going to say x is equal to 24 sine 29. I want you to round to the nearest tenths here, so 24 sine 29 is 11.63. This 3 does nothing to the 6, it stays the same, so I have 11.6. All right. I'm standing here at my 44. How do I know I'm standing at 44? Because that's the angle that gave me. I have the opposite side, and I'm looking for the adjacent side. Tangent is what uses opposite and adjacent. So the tangent of my angle, which is 44, is equal to opposite over adjacent. When x is down low, we divide. So I'm going to say x is equal to, we're going to divide 8 by tangent 44. Okay? let's throw that in the calculator, see what we get. 8 divided by tan 44. I get 8.28. That 8 turns that 2 into a 3. All right. So let's look here. Here we're looking for the angle. When you're looking for the angle, you use the inverse. Okay, those ones with that little -1. So I'm standing here. 8 is my opposite. 12 is my hypotenuse. Okay. That's sine. Sine uses the opposite and the hypotenuse. So the sine of the angle, which is x, is the opposite over the hypotenuse. Okay? So, in my calculator, I'm going to say sine, inverse sine of 8 divided by 12. And that gives me 41.81. The 1 does nothing to the 8, so it stays as 41.8 degrees. All right? Last but not least, standing here at the 42. It wants me to find the hypotenuse, and I have the adjacent. That's the cosine. The cosine uses the adjacent and the hypotenuse. So the cosine of the angle, which is 42, is equal to the adjacent over the hypotenuse. When x is down low, we divide. So I'm going to say x is equal to 21 divided by cosine 42. That's going to give me my answer. 21 divided by cosine 42. And that is 28.25. That 5 turns that 2 into a 3. Okay, so we're done. Good luck on your test tomorrow.